Hello everyone, welcome all of you in Team Deewane IS and GET channel. Already you have given a test on machine tool and we have discussed the solutions of question number 1 to 15. Today we are going to see the question number 16 onwards. So let's discuss. Question number 16. A milling cutter of 70 diameter with 12 teeth is operating at a cutting speed of 22 meter per minute and a feed of 0.05 per tooth. The feed per minute is, so they ask the feed per minute and whatever the given data is, look at that given data. Diameter of the cutter is given 70 number of teeth 12, then ft feed per tooth is 0.05 per tooth. Then we have to find out what is the velocity is equal to pi dn by 60. If you find out in meter per second, then it is pi dn by 60, and from that you can find out v is equal to pi dn only. The v is equal to pi dn, that is nothing but meter per minute. Okay, just put the values, you will get n in rpm as 100 rpm. Then we know ft is equal to fm by nz. Yes, or from fm is equal to ft into n into z. Feed per minute is equal to ft into n into z. So just put the value, you will get answer as a 60 per minute, and that is nothing but option number D. Now next question, question number 17. A hole with 50 diameter and 60 teeth, 60 depth is to be drilled in a mild steel component. The cutting speed is 70 per minute and feed rate is 0.25 revolution. A drill point angle is given 118 degree and over travel is 3 The time in a minute required to drill the hole is. So they ask the time required to drill in minute. Yes. So look at the solution. V velocity is given 70 meter per minute. D 50 is given. Feed 0.25 per revolution. Length is given 60 So just find out the first spindle speed. That is nothing but V is equal to pi dn. Pi dn means meter per minute. So from that V 70 meter per minute already given. Just put the value of diameter in meter, 0.050 meter, pi into n. You will get n as a 445.63 revolution. Then drill point angle is given, that is the 2 alpha is 118 degree. Just find out what is the alpha, that is 118 divided by 2, alpha is equal to 59. Okay, from that we have to find out a distance, that is nothing but d divided by 2 tan alpha. So d means 50 divided by 2 into tan 59. Okay, so that's, we will get the what is your a distance. From that a you will get 15.02. okay, and that a you have to use. Then total length of the drill travel, that is nothing but length of the tool plus this distance, breakthrough distance, plus over travel distance. Okay. And so we have the 60 length plus this 15.02 breakthrough distance plus this 3 distance. You will get L is equal to 78 Then you can find time for drill the hole, that is nothing but L divided by F into N. So feed is going 0.25 per revolution into N in revolution per minute. So you will get will get cancelled, you will get answer in minute, that is nothing but 0.7 minute. Okay, so question number 17 is over. Question number 18. In order to clamp the tool and restrict all degrees of freedom, the 3 to 1 pin method is generally used for such a application. How many pins are used for such a constructions? So what they ask, how many pins are used? So it is based on 3 to 1 principle. So definitely look at the D option, 3 pins at any plane followed by 2 pins at perpendicular plane and 1 pin at other perpendicular plane. So that is option number D. 3 to 1 methods are used for clamping all 12 degrees of freedom of the work material. Yes, it uses 3 pins at any plane followed by 2 pins at a perpendicular plane and 1 pin at the other perpendicular plane. That is indicating your option number D is the correct. Okay. Now next question, how to matches with the 19 question number and list A1 with the list 2. So look at that quick return mechanism. So quick return mechanism is nothing but related to a shaper. Yes. So option P matches with the 3. Okay. Then indexing mechanism, already I have told you in previous video, that is indexing mechanism is related to milling and machine. So R is related to 2. Yes, R is related to 2. And regulating wheel. A regulating wheel is nothing but what we will select. Regulating wheel is centerless grinding. So option number C is matches with that. Look at here, apron mechanism. Okay, apron mechanism is related to a lathe. So you can see the solution what is they have provided. Regulating wheel is used to centralize grinding. Indexing mechanism generally converts a rotating oscillatory motion to a series of a step movements of a output link or a shaft. It is used in a milling machine. Yes, read for apron mechanism is used in lathe, in which apron is attached to the carriage and hangs over the front side of the lathe bed. So quick return mechanism is used whereas there is a need to convert a rotary motion into reciprocating motion. It is used in a shaper. Yes, quick return mechanism is used in the shaper machine. Very easy question to pick up the answer. So answer is the C. Now question number 20. A 200 mm long workpiece is used to cut 25 mm deep slot with the help of HSS side and slab cutter whose diameter is 150 mm and it has 15 teeth. The cutting speed is 75 meter per minute and feed is 0.3 mm per teeth. Then time required to machine the slot will be, okay. So milling machine के ऊपर का problem है. Diameter is given 25 mm. Then depth of the cut is given 25 mm. Diameter of the cutter is D 150 mm. Then what is given, length is given as 200 mm, number of teeth 15, cutting speed in meter per minute is given 75 meter per minute, feed is given 0.3 mm per teeth. So from that cutter over travel, how to find out cutter over travel? That is nothing but L or LA. So or we can find here it is X. So that is formula is under root D into D minus D. So what is D? Small d into capital D minus D. Capital D diameter of the cutter, small d is the depth of cut. From that 25 into 150 minus 25 under root, you will get length of approach, that is 55.90. Here it is, we have find out 55.90 is the length of approach. And by regular formula we have to use velocity is nothing but pi dn, that is in meter per minute. Just put the velocity 75 meter per minute, d, convert that d into meter 0.150 and you will get rpm as 159.15 rpm. Then how to find ft? Ft is nothing but fm by nz. If you have to find fm, that is nothing but ft into nz. Ft is given as 0.3 mm per teeth. Then n value I have already calculated 159.155. Then put the value of number of teeth z. So you will get fm as ft into n into z as 716.19 and unit is 716.2. Unit is mm per minute. Then how to find machining time, slot machining? That is nothing but total length divided by fm, feed of the machine. So we can say table feed. So 200 plus 55.90 divided by 716.19. 200 the length is given and 55 that length of approach is also we have calculated and divided by table feed. So you will get 0.3573 minutes and that is converted into second because options are frame in second, that is 21.44 second and that is one option number 20B. Here it is, look at B option is correct. So now question number 21. A component made of a glass being machined at a material removal rate of 6 mm cube per second using an abrasive grid diameter 150 micrometer. If the abrasive grid diameter is changed to 100 micrometer, the material removal rate become, okay, the material removal rate directly proportional to grid size. We have to remember that, keeping all parameters constant. So from that relationship we can easily find out. So material removal rate we have to find out divided by material removal rate of 1 is equal to grid size of second, that of the grid size of first. So just put the values and unknown parameter is material removal rate second, that is nothing but 4 mm cube per second. So option number A is correct. You have to remember just material removal rate is directly proportional to the size of the grid or grid size. Question number 22. A slot is to be milled by a side and face milling cutter with a 10 teeth and a diameter 150 mm. The cutting speed is 50 meter per minute. Feed is given 0.95 mm per tooth. The table feed in mm per minute will be, what they ask, table feed. So what is the table feed? You have to find out table feed fm, that is nothing but ft into n into z. All the values are given. Z value is 10. Diameter of the cutter is given as 150 mm. Velocity is 50 meter per minute. Feed is given 0.95 meter per tooth, mm per tooth. just find out velocity pi dn meter per minute. 50 is equal to pi into 0.150 into n. Just convert diameter into meter, you will get n is equal to 106.10 rpm. Yes, 106 rpm you will get. Then you have to find out fm, that is nothing but ft into n into z. So 0.95 mm per tooth into 10 tooth into 106 revolution per minute. Tooth will get cancelled. What is remaining? Mm per minute is remaining, and that is fm. And what is the answer? 1007.98 mm per minute is the option number B is closely matches. Now next, in a turning operation, the tool life of the carbide tool was found to be a 20 minute and 100 minute at a cutting speeds of 120 meter per minute and 80 meter per minute respectively. The tool life of a tool under same conditions, but the cutting speed of 100 meter per minute will be in minute, they ask. Okay, so we have to find for 100 meter per minute what will be the tool life. So question number 23 related to tool life equation, Vt raised to n is equal to constant. From that we have to first find out T1 by T2 raised to n is equal to V2 by V1. If you solve for the n, that is nothing but if you take the log of V2 by V1 divided by log of T1 by T2, from that calculation just put ln 80 by 120 is equal to divided by ln 20 by 100, because T1 value is 20, T2 value is 100, you will get one ratio, and that ratio is nothing but 0.252. Then just use the relationship Vt raised to n is equal to constant V1 T1 raised to n is equal to V3 T3 raised to n, because we have to find out T3. Yes, and V3 is also given, that V3 is 100 meter per minute. Okay, just put the value and find out the relationship. From that relationship you will get T3 raised to n is equal to 2.55 minute, and from that just put the value of n as 0.252 and find out T3, and you will get the T3 as a 41.232 minute. Okay, that is option number C. C is the correct. Question number 24. A cylindrical rod is turned in a two passes with the same spindle rpm, feed rate and half diameter. The cutting speed in the second pass is half compared to in the first pass. Then the relationship between the machining time of a first pass Ti and the machining time of the second pass Tij. Okay, they have to ask the relationship. So machining time in case of a turning is given by T is equal to L divided by F cos theta into N, where L is the length of the surface of to be machined, F is the feed rate, theta is the side cutting angle of a tool, and N is the RPM of the spindle. So V is equal to pi dn. Velocity reduced to half. Look at in the question, velocity reduced to half, but at the same time distance to be covered also reduced to half. So what will happen if the velocity reduced to by half and distance at the same time distance to be covered also reduced to be half? So we can say the time remains constant. So what we can conclude here, time at the initial stage is equal to time of the second passes. So Ti is equal to Tij, that is nothing but option number A is the correct for that. Very easy question. 25A, assertion is given, no cutting fluid is used while machining cast iron. Reason, the graphite in the cast iron acts as a lubricant themselves. So we have to pick up the correct one. Yes, definitely. What will happen here? Okay, look at here. Since the graphite present in the cast iron acts as a lubricant, yes, and so that's why no cutting fluid is used while machining the cast iron. So what is that? Both are correct. If both A and R are true, and R is the correct explanation of A, so matches here. So we can say answer is A for the question number 25. Now question number 26. For a tool A, Taylor's tool life exponent n is equal to 0.45 and constant k is 90. Similarly for tool B, n is equal to 0.3 and k 60. The cutting speed in meter per minute above which tool A will have higher tool life than B. Read the properly. The cutting speed in meter per minute above which tool A will have higher tool life than tool B. Okay, I am giving hint over here. So all the conditions for both A and B, tool A constant 90, exponential constant 0.45 is given. Tool B constant k 60, exponential constant 0.3 is given. And if you take the log form of the equations, what will we will get? Log of V1 plus n log of T1 is equal to log of constant, that is expression number 1. What will get second? Log of V2 plus n log of T2 is equal to log of constant 2. at the point of intersection, what will happen? Your Va is equal to Vb and Ta is equal to Tb. Therefore, equating these above conditions, we will get T is equal to 14.89 minute. Yes, from that expression you will get T 14.89 minute. Substitute that T value in tool life equation, will get V is equal to 26.7 meter per minute. Okay, so tool life A will be always higher than tool life B when your cutting velocity should be higher than 26.7 meter per minute. So we can select here option A is a 26.7, option A is a right for that, or you can just put the value, or otherwise second option is just write down the expression of Vt raised to n is equal to constant and just check the all the four options one by one. You will get that A option is correct, and this is the very shortest or easy method to save the time. Otherwise you have to check for all options, okay, which expression is correct. Now question number 27. Through holes of 10 diameter, through holes of 10 diameter are to be drilled in steel plate of 20 thickness. Drill spindle speed is 300 rpm, speed is 0.2 per revolution, and drill point angle is given 120 degree. Assuming drill over travel of 2 the time producing a hole will be. So very easy question. Already we have taken similar question. Diameter is given, so depth through a hole of 10 diameter, thickness is given 20 rotational speed 300 feed 0.2 revolution. Drill point angle or point angle of drill is 2 alpha 120, convert into alpha p divided by 2, 60 degree. Over travel distance is also given 2 How to calculate the breakthrough distance? Already we have discussed that breakthrough distance is equal to d divided by 2 tan alpha. So d is given 10 divided by 2 tan alpha, alpha p is 60. From that you will get A is equal to 2.89, and then find total distance. This is the, you have to consider this 20 thickness, that is 20 plus breakthrough distance 2.89, and over travel distance you will get 24.89. How to find time, machining time? Tm is equal to L divided by F into N, and that will gives you 0.415 minute. Just convert it into second, that will nearly about 25 second. Option B is right for that. Question number 28. A grinding operation require 5 kW power to be carried by the motor. The material removal rate is given 23.65 mm³ per second and the grinding ratio is given 12. Find the wear rate in mm³ per second of the grinding grains of grinding wheel. So just remember the grinding ratio formula. What is the grinding ratio? Here it is the hint: volume of the material removed to the volume of the wheel wear. Volume of the material removed is given as 23.65. Volume of the wheel wear we have to find out, and the grinding ratio is given as a 12. Okay, here it is 12. Just find out wheel wear rate. You will get 1.97 mm³ per second. Option A is closely matches. Next question. Question number 29. Medium carbide steel is a turn on the lathe machine with a cutting velocity 50 meter per minute. Feed rate is 0.8 per revolution and depth of the cut is 1.5 If machining is done on a workpiece having 100 diameter and 100 length, if density of the medium carbide steel is 7850 kg per meter cube, then the after one cut weight loss per part in a grams and material removal rate in mm³ per minute of machining are respectively. So let's discuss the solution. Let d is the initial diameter of the workpiece and d small d is the depth of cut. Already we have take that parameters. N is the number of the revolution of the spindle. Find out what is the number of revolution, that pi dn in velocity is equal to pi dn, that is in meter per minute. Just put the value, you will get n is 159.155 rpm. Time for machining, tm is equal to L divided by F into n, feed into revolutions. So L is 100 and then feed is 0.8 into n. So n is already we have find 159.155 rpm. You will get time machining 0.7854 minute. Then find out the total volume of the material removed. Total volume of the material removed is nothing but area into the feed, and area is calculated as nothing but pi by 4 d inner square minus d outer square into F. Feed is given. So initial diameter is, inner side diameter is 100 and outer diameter we can take 100, and what is the inner is nothing but if you take, how to calculate inner, look at here. Yes, depth of the cut is 1.5 mm, so you can take 2 into 1.53, so 100 minus 3, that is 97. Square of that into 0.8, you will get 371.33 mm cube. Weight loss, how to find out weight loss? Just density is given, density into volume remove already I have calculated, 7.85 into 10 raised to minus 3 into volume remove, you will get that in 2.915 grams. And then lastly you have to find out what will be the material removal rate, that is mm cube per minute. Volume remove in mm cube and time in minute. So volume remove already we have find 371.33 and time is 0.7854 already we have calculated. You will get answer 472.79 mm cube per minute. 472.79 mm cube per minute is the correct option A. Okay, very easy. Now last one is also a simple question, nothing else in that. The time taken to drill a hole of 20 mm thick plate with the drill of rotating 300 rpm, the moving at a feed rate of 0.25 mm per revolution is. Thickness of the plate is given 25 mm, drill and 300 rpm, feed rate is 0.25 mm per revolution. So how to find out machining time? T is equal to L divided by F into N, and from that you will get L is 25, F 0.25 into N revolutions per minute into 300 rpm. Okay, you will get first answer in minute, then convert it into second, just multiply by 60, you will get the answer as 20 second. Okay, option number B is right. Okay, so thank you for watching the channel. Keep watching us. We will meet soon in next upcoming videos. Thank you very much.